we weren't going for power at all on this build. The last thing this car needs is power. We were right before the gearbox broke. It was spinning in fourth gear at 130 miles per hour. And when it finally did give out, our tuner thinks it was making 1,800 horsepower.
Wow. Okay. That is some power. Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we're joined by Cavan Cameron from Horizon Motorsports in the US. Cavan and his dad came on our radar after our recent trip to World Time Attack, where they debuted their Pontiac Hammerhead Time Attack car. And this is no normal Pontiac. It started life as a 1973 Pontiac Firebird. However, really the only Pontiac remaining is the outside skin, and that is now, of course, heavily modified. The interesting part from our perspective, though, is under the skin, it is essentially a Indy Car. And it's quite unique because obviously Indy cars are an open wheel wings and slicks formula, and all of that Indy car technology has been jammed under the skin of this Pontiac Firebird. The reason for this, you might be thinking that's an unusual choice, but the reason for this is that in a past life, Cavan's dad actually owned and ran an Indy car team, and of course as part of this ended up with a huge array of spares just sitting there gathering dust and going to waste. So they decided that this was the match made in heaven. This is an absolute work of art, and considering Cavan came into this project essentially with zero skills, he's used this as his own education essentially, while he's also completing a motorsport engineering degree. All of the design and development, the welding on the chassis has been done primarily by Cavan, and we also talk about how he has leveraged some of the technologies we always hear about now, such as 3D scanning, 3D modeling, with more generic techniques from an earlier time, such as, let's say, cardboard aided design. We talk about where CAD really has its place and where sometimes maybe simpler techniques also absolutely have their place too. Before we jump into our chat, for those who are new to the Tuned In podcast, High Performance Academy is an online training school. We specialize in teaching people how to build performance engines, how to tune EFI, how to construct wiring harnesses. We also cover topics on fabrication, 3D modeling and CAD, race driver education, and data logging, just to name a few. You can find all of our courses at hpacademy.com/courses. All of these courses are delivered in high-definition video modules that you can watch from anywhere in the world, provided you've got an internet connection. This means you can learn from the comfort of your own place, and you can learn at your own pace. All of our courses also come with a 60-day, no questions asked, money-back guarantee. So if you purchase them for any reason at all, decide it wasn't quite what you expected, no problem, let us know. We'll give you a full refund. And for podcast listeners, you can also use the coupon code podcast75. That will get you $75 off the purchase of your very first HPA course. We'll put the coupon code in the show notes to make it nice and easy for you to find. Lastly, if you like free stuff, then I've got a great deal for you. We are constantly partnering with some of the biggest names in the aftermarket performance industry to give away some great prizes. You can always find our latest prize at hpacademy.com/giveaway. It might be an aftermarket ECU or dash. It could be some engine components or engine building tools, or just about anything in between. They are great prizes, and we will ship them free of charge to your door if you're the winner. There's no tricks here, no purchase required to get your name into the draw. All right, enough with our introduction. Let's get into our interview now. All right, Cavan, thanks for joining us today. And as always, let's start by diving into your past and learning how you built up a passion for cars and motorsport.
Yeah, thanks for having me. I've been a long-time listener of the show, and it's awesome to be here.
First time caller.
Yeah.
So the background, what happened? What sort of set you off on this path?
So it's safe to say I've been bitten by the car bug pretty early on. My dad worked Indy Car in a variety of different positions, starting off as a mechanic, then chief mechanic, and eventually up to team owner for a period of time. But I've been bitten by the car bug. My dad's been working on cars since he was a little boy. There's photos of me as a baby sitting in the tubs of Indy cars.
You didn't really have much option.
No, not one bit. I mean, I was always around cars, and I've always been kind of fascinated by mechanical devices. My mom would tell me stories about how I would be super excited to go to construction sites and just watch the vehicles work. So I've just always been bitten by kind of mechanical devices and race cars.
In terms of your dad's involvement with IndyCar, from just chatting off camera before, this actually sort of petered out about the time you were born, if I've got my timing right. So there wasn't really an overlap with that?
No, not really. When my dad retired, it was 2 weeks after I was born. It was around when CART was splitting, and there was the whole feud between the two different series. And he decided he kind of wanted to be out and be a father and raise my sister and I and be able to kind of do what he wanted. And during that time when the series split, he bought up basically all the teams, the stock and spare parts, and he put together 40 Indy cars. Five of them were runners, one of them being the Shell Herta car.
Wow, okay. This kind of, I guess, foreshadows the direction that your life's gone with the Pontiac that we're obviously here to talk about as well. Lots of spare parts hanging around from Indy cars.
Yeah, what's funny is there's not enough cars out there for the amount of spare parts, especially some of those spare parts are not going to be used again because nobody would necessarily want certain ones, or certain ones are good, but they're not being used because a lot of those people are not consuming those parts.
So is it a lack of monocoques that's sort of the limiting factor for building up more cars?
It's lack of engines, really.
Okay.
Yeah, when the series ended, at one point in the series, there was there's three chassis manufacturers, two tire suppliers, and I forget how many engine manufacturers. But most of those teams, what they ended up doing is once the series ended or the cars were done running, they took those engines, just grinded them up.
Oof.
Yeah. So a lot of the IRL engines did that happen too, but we happened to get a few of them. Like there's a few guys out there who have IndyCar IRL engines, the ones that rev. I think they're like a 3.5 liter that rev 10,500. They're naturally aspirated. A few people have those that were made by Chevy. The main one that you see is the Cosworth XD. That's a single turbo Ford Cosworth V8. Those are pretty wicked. If you have seen Rob Daum's recent videos, that's the engine I'm talking about.
Yeah, I think he just got that thing running for the first time.
Yeah, he got it running on a Haltech, which that's pretty.
I thought that was an interesting choice.
Yeah, I think there's probably easier platforms to get that running with.
I mean, I'm not here to knock Haltech. It's just not the first ECU that would come to mind when you think of 10,000 plus RPM in a Indy Car V8. But yeah, all power to him.
Yeah, and him transitioning away from the spark box, I was in my head, like when I was talking to my dad about it, we were like, we have no idea how he's going to get around using that. And I guess he just stopped using it.
We've gone down a bit of a tangent here, but it is interesting considering I've just come off the back of watching that video. But obviously, a lot of people listening will have no clue what we're talking about. So, can you just elaborate on this spark box and why that would cause a problem with essentially almost any aftermarket ECU?
Yeah, so during that era of cars, kind of electronic management, even though it was the 90s, it was still kind of a fairly new technology.
Just as in its infancy, really.
Yeah, for sure. And data logging wasn't really as prevalent as it is today, where you're looking at every little thing. I mean, I remember like you weren't allowed to use traction control. Everything back then was completely controlled by a driver. It was not shift without lift or auto rev match downshift or TC or any kind of stability control or ABS. Those cars were really driver's cars, and the ECU and the whole data system was there to either just run the engine or collect data, and there wasn't even a ton of data to collect due to restrictions. But because of its infancy, the systems aren't as refined as they are today, and instead of just controlling the spark through the ECU, they ended up having kind of a weird system where the ECU would communicate to a spark box, which then would go to the coils. So it was just kind of this tricky system, and there's not like a lot of technical documents out there to really understand entirely how it would work, especially integrating with another piece.
Kind of reading between the lines and watching that video, it sounds like that spark box was part capacitive discharge ignition system to give a very high energy spark, which is obviously needed with methanol and positive boost pressure, but also possibly did some kind of multiplexing in terms of actually controlling the spark distribution, almost like an electronic distributor. So it took that part out of the ECU's control. Hence, the ECU needed to be able to speak the same language as the spark box. Otherwise, where the spark was going to go at what time was going to be anyone's guess. So again, a little bit of a tangent, but we'll pull things back to the present. You obviously, it sounds like, have had a very high level introduction to the world of motorsport, sort of an introduction that most of us never get to see. How's that sort of shaped the direction that you want to pursue your career?
So that's a really good question, and that's a good observation. I've kind of grown up with this IndyCar mentality of you don't build stuff just so it works. You build stuff so it not only works, but it's the best it possibly can be. It has several jobs, and it looks good. And the last thing you want to do is have a race car that goes out that looks like crap. I mean, if you have the time to wipe it down or clean it, you're probably going to be inspecting their parts of it, and at the end of the day, it's going to look better. So using kind of a basic IndyCar mentality of everything needs to be quality and right, it's gotten me quite far. I would say for a career, I really like design. I'm very interested in the design aspect of stuff. Being a race engineer or performance engineer would also be interesting. Being able to look at a car and use driver feedback along with other information to try to extract that performance from the car. But as I've designed parts on this car and worked with other companies, I just love designing stuff and coming up with unique solutions for stuff. But as cars are going to more of a spec series or more restricted, it's kind of restricting what you can do from a design perspective.
I like that you brought that up. I was going to ask a question along exactly those lines. You sort of were talking about designing parts so that they not only look good, but perform as best they possibly can. And I've always been a bit of a fan of that sort of form follows function mentality as well. When you're coming at this with an IndyCar mentality, though, obviously that series is incredibly tightly restricted in so much as you can't do whatever you want to do. You've got to do it within a very tight set of rules. Now, what you've built for World Time Attack, and obviously we're going to get deeper into this, but just at a high level at the moment, yes, there is still a rule book for World Time Attack, but fair to say it's fairly broad. Is that a situation where when you've got a blank sheet of paper and you can go in absolutely any direction, it's almost harder than having a tight little box that you can work within in a set of rules? Is too much freedom almost detrimental?
It's funny because you're looking at a modern series like IndyCar where you're completely restricted. You're only allowed to use parts that were bought or approved by the Dallara manufacturer, the team, or not the team, but the series. That's super restrictive. You can't really do anything. You're just looking at kind of ways to take out friction and optimize what's there. Obviously, like what you said with the time attack cars or custom cars, you can do whatever you want. And it does lead to scenarios where you don't sleep at night because you get in bed and you go, oh, wait, this part that I just spent 2 days on, what if I do it this way instead? But for me, as an individual, that's what gets me excited. Being able to just sit there and just think and come up with unique solutions or just solutions to a problem. So I definitely think those are two ends of the spectrum. I think somewhere in the middle for like a bespoke, like real racing series is probably good. Kind of like how kart was back in the day where yes, you had like a tub and you had certain things you couldn't modify, like the engine and gear and most likely gearbox. I don't remember the exact rules for that series, but back then you could really go through and change a lot of other stuff. Like they were doing serious wind tunnel programs where they were making front wings, rear wings, full aero kits, under wings, coming up with different suspension to achieve different roll centers or using different philosophies. Like one year, my dad was talking about how at the Speedway, they were trying to figure out how to get a benefit. Like they were looking at the rules of what they could possibly do to get a leg up on the competition. And what they ended up coming up with from looking at the rules is they wanted to go for the minimum track width possible with the car. And you might be thinking like, what is that going to do? Don't you want more track width for more stability to go through the corner? Well, at the end of the day, Indy's all about drag. You're trying to minimize drag. And by going in to the minimum track width they could, they were able to increase their speed by 3 miles per hour compared to the competitor, which lap by lap is a major benefit, which due to modern series being super restrictive, you can't come up with something like that.
The rule book's just changed now.
Yeah. Yeah. The rule book is you have the car you're going to run, and it's really down to driver. And I mean, even if you look at the cars now, I think they're like 12 or 15 years old on that platform. There's no needle in that haystack. Everybody knows what the setup is.
Yeah, I think that's one of the pros and cons, I guess, with a spec series like IndyCar versus a constructors series like Formula One. Although I would argue that Formula One, as time goes by, is almost moving towards a spec series. The rule set is so tight that, all the cars, if you painted them white, you'd be hard pressed to tell a Ferrari from a Red Bull from a Mercedes, for example. But when the series specifications are so limited, the budgets are very high, obviously at the pointy end, and every iteration and part change has been done, tested, simulated. So as you say, everyone knows exactly what's going to happen. There's no needle left in the haystack to find. I want to just come back a little bit, and I admit we are getting out of order. We will get this show on the road soon, but because you mentioned this, lying in bed awake, and you sort of come to this realization that there's a better way of designing the part that you've just spent the last 2 days developing. I just want to jump into mindset, and I'm not a designer. I wouldn't class myself as a creative, so that might be my problem. But what I find is when I've come up with a solution for a particular problem, I'm sort of almost laser focused at that point. I've got my blinders on, and there is nothing that's going to get me to think about a completely unique approach to that problem. How do you go about coming back from something you've already designed, you've already got a solution in mind? Why start thinking about different ways to skin that particular cat, for example?
So at least for me, I'm always looking for a way to improve. A lot of times when you're building, like, let's say you're looking at an entire project, not just designing one part, you don't necessarily see that one part is just, I got to get this done. A lot of times when you do a project, you're thinking 20 steps ahead and only acting on one or two at a time, and having a real plan at 5 steps ahead. So when you design a component, especially for something that is going to be motorsports grade and is going to be cohesive piece, when I'm looking at something, I'm trying to make it do as many jobs as possible. Like if you look at Formula One parts, I mean, they're doing like a million things at once. There's not a single straight line on that part. And I'm not saying you have to go to that level of complexity, but like a mount doesn't have to just be a mount. It can be something to grab onto this part or grab this part. Or I'm trying to think of a better example. Like, for example, like an engine, it can be a stressed member in some cases, as long as it's been designed that way, and it can be part of your chassis. There's no need to build a chassis around it a lot of times. It can be your structure. So if you can kind of look at something and go, hey, there's actually a better way to do it, and it's actually simpler at the end of the day, it's usually good to take that, because the last thing you want to do is be done with your project, look at it and go, man, I should have done that. I should have done that idea.
So essentially a more holistic approach to the design of a part, looking at it in its entirety and its function within the vehicle, as opposed to just solely what that particular part needs to achieve.
Yeah, and that doesn't apply to every part. Like some parts you just are like, okay, I just need a bracket right here to mount this one tab. You just do that. You just make a bracket, you put on, you weld it, and then you get the whole chassis powder coated or something like that. But there's certain, like the more complex stuff that maybe potentially will show more weight, you probably want to integrate those components together to minimize that weight.
Okay. All right, let's dive back a little bit and we'll sort of talk about where you're headed to at the moment in terms of your formal sort of education. Motorsport engineering degree, is that what you're up to at the moment?
Yeah, that is correct. So when I started college, I'm actually in my senior year now, but when I started college, it was at IUPUI in Indianapolis, and that was a joint effort between IU and Purdue. And at the time, that was the only place where you can get, and I actually, that's still to this day, this is the only place in America where you can get a certified bachelor's in motorsports engineering. And you can even get it with a dual degree. I don't know if they're still offering that, but a dual degree between mechanical engineering and motorsports. So now it's my senior year, and a year and a half ago there was a split, and I'm on the Purdue side. Purdue it's now under Purdue in West Lafayette, but the program's still in Indianapolis. So for the degree, you generally start with general engineering classes, and after a year or two in the program, you start getting into your motorsports classes where you're starting with introductory stuff like CAD and more math classes. Eventually, when you get to your junior year, you're getting into the heavy concepts of vehicle dynamics, aerodynamics, design, race engineering, and you're applying a lot of these classes are sharing the same concepts because it's all interworking. Like the person who's designing the aero is going to be looking at all these specific metrics and values and coefficients, and that's all going to eventually equate to a balance with a downforce number at a certain speed. And that information is going to be used by the person who's doing the vehicle dynamics to design the suspension. And that person who's using the information to design the suspension is eventually going to be needing that to pick materials. And so then you have someone who's designing or choosing or designing a material that you would need. So it's all interrelated, and a lot of these classes end up sharing a lot of the same concepts.
So, I mean, it sounds broadly like a mechanical engineering degree, but with a very specific slant towards motorsports. Is that fair?
Yeah, that's a really good way to that's a good way to sum it up.
Which, I mean, makes sense. Most of the guests that we have on this podcast ultimately end up going through some kind of mechanical engineering degree. So obviously there's a lot of crossover, but yes, there are some specific concepts that are motorsport specific. Just so I can get a bit of a read on this, how many students go through this degree and graduate each year?
It's really hard to say.
I mean, ballpark me, we're talking 50 or 1,000?
I think my class is probably going to be anywhere from like 30 to 60 people, but the freshman class entering in, I think, is 150, 200 and something people.
So there's a fair bit of attrition over the years.
Yeah, so the program's really picking up, especially under Purdue's kind of guidance.
Sure. All right. And when you come out of this degree, I guess one of the problems always is this balance between the technical knowledge and the hands-on experience. You know, it's the catch-22 when you apply for a job and they ask for 5 years experience. Cool, how am I going to get 5 years experience when every job I apply for needs 5 years experience? Obviously, you're not quite out the other end of that, but have you got any insight into what that does actually look like out there in the sort of big bad world?
Yeah, so I'm going to say what the program director said, and I'm going to tell you my personal experience. So the program director, his name is Chris Finch, and one of the first classes that I took with him was called Intro to Motorsports. And it was a class to help you decide, is this the right degree for me? Which is kind of funny because most of the time you don't have that for a major. You pick the major you're going to do, you go through 4 years, and then you're done.
You hope that you got it right.
Yeah. But because this degree is so specialized and because it's a big decision, he has this class to help you go over the general concepts of the entire thing, meet people in the industry. And for me, that made me go, oh man, I really want to do this. For other people, they went, no, I'm dropping out or I'm going to ME. So what he said is you need to go out and basically just give people your time. Like racing is racing. You're going to learn something no matter what level it is, whether it's a go-kart, a GT4, like a Le Mans car. That's silly to think of, but no matter what experience you have, it's going to translate. I mean, back in the 60s, when they were first putting airfoils on cars, they were dealing with people who either learned stuff from the war or people who learned stuff from working on planes. So the big thing is you want to learn from other areas of your life and apply them to racing or to some other project you're working on. But in terms of what you need to do is you need to go out and kind of volunteer your time because a lot of racing teams, they're running on tight budgets and they don't have the time or the money to employ someone. But a lot of people are willing to share the knowledge that they've learned, especially at lower levels. So it's going out and kind of don't be afraid to get your hands dirty. Just because you're an engineer doesn't mean that you can't turn a wrench. A lot of times, as a fresh engineering grad, a lot of mechanics don't really like the stuff that you put out because it's not realistic. Like, let's say you design a really neat machined part. They go, "Hey, because of the tooling, I can't get a bit in there.
Yeah. I think that's always a bit of a disconnect when people start learning how to use CAD, because it is so powerful. And I mean, you can draw anything your mind could come up with, but when you don't understand the manufacturing steps, the processes, you don't have that sort of design for manufacture in mind, you can very, very easily design parts that are just simply impossible, or way too expensive to actually machine and make.
Yeah, so one of the big things is people want experience because experience helps you help them. So one of the things that I learned to do is learn how to physically make parts. Don't necessarily to go out and design them, just learn how to make the part. I started learning how to machine on a Bridgeport, and that's a lot of singular straight line movements, but it's still three-dimensional. And you learn that eventually, like, hey, every time I move this part, I can't find the zero again. So that would, now you understand why every time you move a part, it adds cost. I'm kind of getting estranged from the question, but at the end of the day, you need to go out and either volunteer your time or find jobs or experiences that surround the job your goal is. So don't go into school with no goal, just saying I'm going to get my degree and work in engineering. It's like, okay, what kind of engineering are you going to do? So what I would say is form a goal, figure out what steps you need to do to find that goal, and then once you've figured out those steps, figure out if there's anything you need to do further than that and execute those steps. And don't say no to opportunities. I mean, a lot of the reason why Hammerhead became what it was is because we ended up saying yes or we'll think about it. And through forming relationships, you can get to better and better places. So the big thing is don't say no to big opportunities, have a plan, and be okay to get your hands dirty and learn things surrounding the job that you're going to do.
Yeah, no, that all makes sense. I mean, you've got a very nice rolling CV that is going to be probably a powerful play card for when you actually do sort of look for work. And on that note, sort of what does that look like for you? So everything goes perfectly, 5 years time, you've already mentioned that design is kind of your passion. That's the angle of this degree that you've enjoyed the most. Where do you see yourself working? Is this going to be Indy Car, Formula One, sports car teams, OE manufacturer, none of the above?
That's a really good question. When I entered school, I was talking about you got to have a goal for yourself. So my goal was to become a lead race engineer for an IndyCar team. And I still think that would be a really good job. It would be really good to do. But I want to design components, at least in the beginning. Eventually, I could transform into that role. I know a lot of people who start off as design engineers, or they started off designing stuff, and after about 10 years or 5 years, they were saying, okay, I've had enough of this. I'm going to start doing race engineering. And that long term, I think that is kind of my goal, is to become a design engineer, do that for 5, 10, 15 years, and then potentially do race engineering. It's hard to say. I don't really have a exact plan at the moment. I could see due to the design stuff, I would have to work in kind of like the surrounding industries. So I have to either work for Dallara or Extract or
not the actual teams themselves, because the teams can't make parts for these cars.
Yes, exactly.
Yeah, okay. No, that makes sense. If you're a fan of the podcast and you're interested in topics like engine tuning, automotive wiring, performance engine building, 3D modeling in CAD, or anything else in the high-performance industry, I have something that you might be interested in. Introducing the High Performance Academy VIP package. This package of courses gives you lifetime access to all of HPA's online training for one price. These courses cover everything from tuning and reflashing petrol and diesel engines, through to motorsport wiring, engine building, fabrication, design, car setup, and plenty more. Right now, you can get $500 off High Performance Academy's VIP package using the code PODCAST500 at checkout. Becoming a VIP means you'll never pay for another course again. You'll get instant access to all 40 plus courses we currently offer, plus every new course we ever release in the future. Want to define maps or tune with WinOLS? Curious about CAN bus devices, or how CAD can help make your dream build a reality? These in-depth topics, as well as many others, each have their own dedicated course that are going to help you master whatever it is you want to learn. And as a VIP member, you're not just getting the courses, you'll also join HPA's online community with lifetime access to our member forums and members' webinar lessons. Again, the code is podcast500 for that $500 discount. Just head over to hpacademy.com to check out the full VIP package and everything it contains. All right, let's get back to the episode. All right, I think it's probably time to sort of stop teasing around the edges with this Hammerhead build and dive into it head first and find out what it is. So on that very note, what is the Hammerhead and how did this project even come about?
Yeah, so Hammerhead is a 1973 Pontiac Firebird, and it's got the chassis and kind of framework of a 1997 to 2002 kart or Indy Car. But over time, it started getting more aero, and it really started off as like kind of a fun street car that we could take autocrossing.
That escalated quickly.
Yeah, it escalated super quickly, and budget creep also escalated even faster. So what we ended up doing is we found a car on eBay in Detroit, Michigan, and it was an old rusted out drag car. Literally halfway down the car was rusted out. It was unusable. We had to cut it away. So we ended up with basically a top half of a Firebird and a bunch of spare parts from Indy cars that were developed basically by F1 engineers. And we were like, well, if we could build a tube chassis, and we spent 6 months, we could build a pretty fun, fast car. So we bought a junkyard LS and got a Corvette torque tube, and we had a spare extract gearbox, and we ended up mounting that all together. And we started placing suspension where it could go and seats. And we're like, hey, I think with this arrangement, we could make this work.
So was this from the ground up always going to be this amalgamation of Pontiac Firebird plus IndyCar componentry that didn't just evolve as it went along?
Yeah. From the very beginning, we decided we're going to do a tube chassis with IndyCar parts, with a junkyard LS, and using not necessarily as many IndyCar components as possible, but components that would be important to the build.
Now, just for technical correctness, as we talked about this when we caught up at World Time Attack, technically it is the kart series that you're taking parts from, but we're sort of incorrectly using the term IndyCar interchangeably, and people can just accept that or not as they want. That's correct?
Yeah, that's correct. Yeah, we're kind of mixing IndyCar and kart. Technically, it's kart, but I'll respond to IndyCar and all that. I'm not picky.
I just find IndyCar just rolls off the tongue a little easier than kart. So now that we've got that out of the way, we'll carry on.
Yeah, kart car doesn't really roll off the tongue like IndyCar.
Nah, it's a bit weird.
Yeah, so we took all these IndyCar components, and we were like, it's too nice to just leave on the shelf, and it would take forever to build and manufacture some of these parts. So we put it all together, and the build did not take 6 months. It took, the first time we finished V1, it took about 2.5, 3 years. And then from there, we learned a lot about the car, changed a few things. And I mean, I don't even know what version we're on now, but it's just a wild vehicle. It's gone through a lot of aero development, and we're going to go through even more to get just better results. It's just going to be crazy. But in general, Hammerhead is a Pontiac with the skeleton of an Indy car underneath, and it just kind of evolved over time to get some kind of time attack / hill climb aero on top of it.
Okay, I have literally so many questions. When you're diving into a project that's this complicated, it's sort of a case of taking your time and planning properly rather than sort of jumping in, bending up some tubes and tigging them together can pay dividends, because you don't end up finding out 6 months into the project that you've put a component somewhere where it interferes with something else. This sort of begs the question, on face value would seem to be the perfect project for a full development of the whole car in CAD before you start making anything. Did that happen? And if not, why not?
So that did not happen. It would have been nice to do that. At the time, I didn't even know how to weld, fabricate, really build cars much at all, let alone how to use CAD. I didn't really learn how to use CAD until the end of my freshman year. And once I started learning how to use CAD, I was like, hey, this is a lot easier. So we were making stuff in the garage and doing sketches. And I go, hey, Dad, give me like 15 minutes and I'll be right back. And he goes, okay. So I draw the entire piece I want on CAD and I show him it. And he goes, when did you do this? I go, 15 minutes ago. And he goes, you can do it that fast using this software? I go, yeah. And he's like, oh man, maybe we need to make more components with this. This kind of build has started off as my dad teaching me how to do stuff, and now it's kind of becoming
you teaching your dad.
yeah. So we're a really good pairing because he's bringing old school philosophies and older school build techniques, while I'm also bringing in new school technology and new school build techniques.
Yeah. I think a lot of people, I'm glad that you went down this path, because I think a lot of people these days, younger enthusiasts growing up, kind of think that if they don't have access to a 3D scanner, 3D modeling and CAD software, various 3D printers, that they're dead in the water and there's no point even starting. So obviously we didn't have access to all of this equipment decades ago, and people were always building cars, so it's totally possible. So I just appreciate the fact that you've managed to build this work of art without necessarily leveraging all of that right from the get-go. The other thing, I'm just interested to get your perspective on this. You just mentioned modeling a part in 15 minutes, and that's great. Obviously, there is a time commitment if you did want to go to the extent of developing this whole car in the virtual world before you start manufacturing anything. How do you trade off the time spent doing that before you start building versus just getting stuck in building and maybe finding that you've gone down some dead ends that you have to sort of come back from and wasting a bit of time that way? Which one do you think sort of comes out more time efficient?
I love that question because a lot of people think that you have to design everything in CAD and that's going to make your life easy. Sometimes it really doesn't make your life easy. Sometimes you just wasted half your day drawing stuff on CAD when you really could have just gone over and made the part. I think there's extremes to this, where if the part is extremely simple, where you could literally just sketch it and draw it, or sketch it and make it, and under the time it would take for you to draw it and then use that to make something, it's not worth using. Like a really simple tab or bracket, not going to be worth your time unless you're making 100 of them.
The flip side of that, though, is if you are designing a bracket that you know can be multi-purpose, then use the sheet metal modeling functions in the likes of Fusion. Maybe send that off to Send, Cut, Send, and a week later you get a pack of 100 of these little tabs, and you can use them on projects down the road as well. There's some value in there. So I don't think there's a black and white answer, is there?
No, not really. I would say it really depends on your purpose and your production capabilities. If you're going to spend the time, there's really not a black and white answer. I'm thinking of like a million different ways this could be a yes or a no, because there's the philosophy of I'm going to design every little bit of this car in CAD, and then I'm going to work on producing those parts. Okay. If you design every little bit in CAD, are you going to manually bend all the tubing, or are you going to send it out to a laser CNC bender, or like, are you going to have everything machined by 5-axis or 3-axis? It's all about really what your building capabilities are. And then because you have to design around what your building capabilities are. If you can 5-axis CNC everything, that's really nice. You can almost make any shape you want with a machine part as long as the tool can get there. But if you only have a Bridgeport, you're going to have to kind of stick to simple designs and understand that you can't go super complicated. So I would say if you're going to design CAD, you need to know what you're designing around. And then sometimes it's an all or nothing situation. Sometimes it's just a quick tab. Sometimes it's more complicated. It's a really good question. It's one that's very hard to answer, though.
No, I do appreciate that. It's definitely not something where I was expecting a black and white answer. It's obviously going to depend on the specific application, what you're trying to achieve. And as you mentioned there, which is a good point, you're understanding the production methodology that you have available to you as well. I would go out on a limb and guess that one of the advantages you've got using all of these IndyCar components is the likes of your suspension kinematics are really locked into what was developed for IndyCar. So it's not a case of going through permutations of developing the suspension kinematics in a CAD package either. That's kind of already defined, and you kind of know, I'm guessing there's going to be no sort of interference between these components. That sort of takes a big portion out of the benefit of CAD. Again, I'm purely guessing here. I'm interested in how you developed your skills, because you sort of said when you started this project, you didn't really know anything about fabrication. I mean, I've crawled over this car fairly extensively at World Time Attack, and I couldn't really see anything that suggests you're new to all of this. So give us a rundown on how you became a fabricator.
So I'm not exactly much of a fabricator. I'm really good at welding, and I can do some level of fabrication. My dad's a lot better of a fabricator than I am. I can fabricate really basic stuff. As it gets more complicated, I just need more time than what my dad would need. But the big thing is that there's more than one benefit to having a stockpile of IndyCar parts. I'm a major perfectionist. I look at something and I think I can do it to the same level or ability someone else can, whether or not I can. And I'm pretty determined. So when I was learning how to weld, a fabricator from IndyCar, or the Aero McLaren IndyCar team came over, and he welded a few critical things at the very beginning. And then he showed me the ropes and had me try a few welds. And he goes, "Hey, man, like these welds are all good. You could weld the rest of the car like this." And my welds were not as nice as they are now. So to answer your question, three things made me a lot better at anything. It was having something to reference off of. So that's that goal. So I would go back, look at IndyCar components and say, oh, that's how they welded it. That's how they got around this. And oh, you can weld it that way. Or this is how their welds looked. I need to copy that. And understanding that you need time to get good at something. You're not going, no matter how much I believe I'm going to be good at something when I first try it, it's going to take time. That car, I don't know how many hours of welding it has, but it's got to be more than like 2,000 or 3,000 hours of welding in it. It's hard to tell, but that chassis has so much tubing in it. It was a lot of joints to weld, and none of them were really easy to reach. And then also on top of that, challenge yourself. Like, yeah, like a lot of this stuff is hard to do, and it takes a lot of time to learn. But just because you don't do well one day doesn't mean you're not going to do well the next day.
I think as a perfectionist, that is always a bitter pill to swallow, though. You can understand all of the technical settings on a TIG welder. You understand intimately how you need to set that welder up for a particular material and thickness, but then nothing can replace hours on the end of that torch once it actually comes down to laying a weld. You've just got to put in the hours.
100%. Like, I would not be good at anything. Like, it's ridiculous to say I'm going to go win a gold medal at this event and have done it 2 times before. It's like, those people, what are they doing? They wake up at 5 a.m, they're working out, and they're doing everything it takes to be the best at it. So I'm not saying you have to do that to be good at something. It's just small, dedicated efforts every day or some consistent manner will make you better at any task. So because we were working on the car literally every single day for years, it allowed me an opportunity to get better at many different things.
There's an obvious question that comes up with this, and I think this is typical of any large-scale project where you're learning skills, be it fabrication, be it motorsport wiring, or anything in between. You're not going to be great at it the first time you lay down a weld. So I'm guessing here that a year, 2 years into the project, when your skill set on the TIG is far surpassed where it was at the start, you're probably starting to look back at some of your earlier welds and maybe shake your head a little bit. How do you weigh up getting the project finished? So basically what I'm saying here is not redoing the whole thing from scratch, but also putting out a product that is high quality that you can be proud of, because a car at this level is going to be scrutinized by the internet.
Yeah, man. I'm so glad you said that, because the internet is not your friend when it comes to that stuff. They will, if you screwed up, they will tell you. And most of the people, they're kind of bandwagons, like they don't really know. They're just grabbing onto what the first comment said. But occasionally one comment will slip through, or 2 comments will slip through that are actual genuine advice that are there to help you. And a few of those comments, I reach out to those people. I'm like, hey, can you explain this to me a little bit? And those end up helping me a lot. So I'm going to jump back a little bit. But when I wouldn't do something the way I wanted, I would research and look at what are other people doing to achieve the results they're getting. So as the project went on, I ended up finding out like, hey, this helps me a lot. I can get away with this and this kind of radius. I can get away with this, or I can do this. or hey, this is the cup they're using. Like I ended up changing cups to one of those ones with the diffusers in it, which helped the gas coverage a lot. And then I could move the tungsten out further and see welds a lot better. So what I would say is none of the welds on the car were bad. None of them were going to fail or were not structurally sound. Some of them just didn't look like the rest or were super pretty. So the ones that were the absolute worst, because I didn't want to spend all my time grinding and re-welding stuff, because at the end of the day, like when I'd grind back the weld, it was completely fine. There was no pits, there was no corrosion, there was no contamination.
So it was an aesthetic problem, not a mechanical strength issue.
Yes, 100%. So I just took the ones that were in the most plain sight that I thought were the ugliest, and I ground them back and re-welded it, and they look perfect. So yeah, just chose the worst ones in the most plain view.
Okay. Material choice for the tube frame chassis. What did you choose? What did you go with?
Steel DOM.
Okay, so nothing exotic, nice and easy to weld.
Yeah, so for people who don't know what DOM is drawn over mandrel, and it's super high strength, and it's an easy metal to weld.
You're not getting into the exotics like chromoly where you have to be much more careful about the amount of heat input into the weld.
Yeah, so the big thing about chromoly or like a material like Docol, they have, I believe, chromium in them. So you have to be super careful about temperature with those metals. They can, most of the time, welds don't fail. It's like right next to the weld, because when you weld something, you're obviously turning it to liquid, and then that cools down and it hardens. So that's why, like a suspension member, when you weld it, you're using a person who really knows how to weld to do that, because it's thinner metal, a more intricate, exotic metal, but they end up with stress points, and you have to heat treat it to normalize it or anneal it or deal with getting rid of those non-uniform stresses in that metal. So the reason why I mentioned the chromium is because if you use too high of a temp, you can burn certain materials out of it or change the characteristics, and those welds are not that chromoly anymore. It's some other form of metal that isn't as high strength as what you initially used or spec'd out. So the reason why we use DOM is because I wasn't experienced. We did this project to help me get experience and learn. So I could go and make mistakes, not that I made like a ton of mistakes, and learn a lot. Now with my level of skill, I probably would go to a chromoly or a more exotic metal, because it's got higher strength, which means you can use thinner wall or thinner or smaller diameter tubing to get the same strength as with like a DOM. DOM is still a very good material. It's high strength, but it's just going to be a little bit heavier than like a chromoly.
Could you give me an idea across the full tube chassis? What would that difference in weight between just mild steel DOM and the likes of chromoly tube? Would we be talking, a 10% weight reduction, more, less?
It's really hard to say. I completely forget. I think we could probably realistically even take like 50 pounds or 40 pounds out of our chassis right now in terms of the tubing. But if we put more aero on it, I probably wouldn't want to take that out.
Yeah, that's always a bit of a balancing act there, weighing up strength versus weight. So yeah, I'd probably take a little bit of additional weight for a little additional strength any day of the week as well.
Yeah, and like a safety thing. Like one of the things that we did is we built up around the foot box a lot, because the last thing we want to do is have like a corner or side impact where your feet get stuck and you can't get out of the car. So I think if we switched to, like, if the whole thing was built using chromoly, you could probably use a thinner wall tubing. I probably wouldn't have changed the diameter of the tubing. I think you could probably lose, about 10-15% off the weight of the car.
Okay, so it's not an insignificant weight saving.
Yeah, like at the end of the day, like 10% on something that weighs roughly 400 or 500 pounds. That's not actually what our chassis weighs, but that could help a lot.
Yeah, absolutely. I'm just interested, a little outside of my personal experience, but Docol, which you mentioned, which kind of, as I understand it, is the next rung up the ladder from chromoly, kind of the strength advantage of chromoly, but without the intricacies of welding, sort of a little bit more like welding mild steel. Is that correct? Not so sensitive to the amount of heat?
Yeah, you're completely right. The way you describe it is the way I would describe it. It's a mix between, well, I mean, in my head, it's a mix between chromoly and DOM, where it's that DOM's being a more mild steel. From my experience of welding dough call stuff, some people love it, some people hate it. I don't know. I feel like it's a good stepping stone if your welding isn't 100% there and you're still trying to get weight off of a vehicle. In my head, I would just fully commit to the chromoly. I just don't really like the way Docol welds with the way I weld. Like I can weld stainless steel, steel, aluminum. I can switch between those. Like I can weld for an hour with one metal and an hour with another and switch back and forth like no problem. It's a really weird metal to weld.
Okay.
So with steels, when you're under the hood and you're heating up the metal, you'll see a puddle form and you have a sharp tungsten. You can start to see the heat generate, then you see the puddle form, and then you kind of change the size of it. With dough call, I don't feel like I can predict it as well. Probably partially due to not being having a ton of experience with it, but in my head, when I have welded chromoly, it melts like really quick, and you can't blast it with temperature. You have to keep the temp low the whole time and run fast. Dough call, I feel like the puddle doesn't do what I want.
Right. So a little less predictable.
Yeah, and that's my case. Someone might come along and say, "Hey, you're full of it," and I'm like, it's my kind of thing. I would rather just. You can tell it's a mix because the front half melts a certain way and the back half melts a certain way. So that's my experience, but someone can tell me otherwise. So.
All right. Let's move on. Just in terms of layout of the chassis, sort of jigging it, fixtures, however, it'll be very easy if you don't get this right to sort of have a beautiful looking chassis that's twisted like a pretzel and essentially useless. So how did you go about making sure everything was in exactly the right position, laid out correctly, square, true, etc.?
Yeah, that's a really good question. Scale is a super important thing when you're thinking about this. If you have something that's pretty small, your tolerances are a lot smaller. If something gets a lot bigger, your tolerances are generally larger, but you want to try to keep them potentially around the same, especially if you're using a highly developed suspension, that if you can change stuff by such a small amount and it actually matters. So for us, I was talking about how our shop isn't really the most top tier, most technologically advanced place ever. It's really, the car was built in one bay and it went up like 300 times up and down on a lift. And we didn't even have a laser at the beginning of the project. Like a lot of people, I think we were using Klein tools. We got one of those lasers recently. And man, that thing is a ton of help. Like you can set it somewhere and we use it to level setup pads.
Yeah, they're so helpful, aren't they?
Yeah, it's awesome. So a lot of people, what they do is they use like a chassis table or a flat plate, something that's super heavy machined, and you can build a fixture around it, or you can hold different parts of the chassis down as you weld it. And then before you let it go, you heat up those joints and de-stress the metal so then it will stay in position, because as you weld, it's pulling and shrinking. And because you can't weld all the joints at once, and cool it all at once, it's going to pull in different places unevenly, which will, even if you build everything perfectly to spec, it could move. So one of the things that I did to make sure that it wouldn't pull and shrink a lot is if I did a weld on one side, I would do the weld on the other side.
So heat management, essentially.
Yeah, and then when I would weld, I wouldn't use the maximum amount of heat I could for that weld. I'd use the minimum, and I'd go as fast as I could across the joint, just to keep the heat down. And because, like, I guess time is money, so I didn't want to spend all day trying to make my welds look perfect. I was like, I've seen people weld faster than what I can do, and their welds look a lot better. So I'm going to try to improve that aspect as well. One of the things we did is the first part of the chassis we built was kind of the front section. And we had a miniature jig that we built off of a Reynard tub so we could get the suspension points right. And we had little pieces built for that. And we bolted them in and then built the rest of the chassis, or rest of the front of the chassis there. And then attached that to what we call the power unit, which is the engine, torque tube, and gearbox. And once we had that all kind of properly in line with each other and positioned, we started building the rest of the chassis back.
Just in terms of sort of some of the key geometrical constraints like wheelbase and track, How closely does that match the Indy Car? Was it adapted to suit the Pontiac chassis?
So what's funny is the later Indy cars ended up really long, like 120 plus inch wheelbases, which when you stand up next to one of those cars, they're not like, I mean, they're wide. They're I think 82 inches wide, but you're kind of like, I mean, this thing looks longer than it is. It's very long for how wide it is. Our car, we're 111 inch wheelbase, 3 inches longer than stock. So it still is a pretty long car, but not nearly as long as a champ car.
I guess as soon as you get the carbon monocoque out of the equation, you can essentially do whatever you want, though.
Yeah, we can pretty much change the wheelbase as long as it's not by too significant of a margin. Because this is kind of getting off track, but the roll center, like you got to be careful changing stuff because the roll centers can get screwed up.
Okay, roll centers are a difficult topic to talk about without the benefit of some drawings, but at a high level, could you maybe explain how changing the roll center will adjust the way that the car handles?
So to really understand what a roll center is doing, you have to understand kind of the basic concept of a moment. So a moment, and everybody understands what this is because you've used a wrench before. So you're not going to be able to, if you're trying to loosen a nut, you're not going to put your hand on the middle of the wrench. You're going to put it on the very end. That is force times distance. The roll center is doing the same thing. As you get it closer and further away from the center mass of the vehicle, it's going to do different things to the suspension. And at the end of the day, it's changing potentially how much the car will roll. Well, roll side to side, front to back is going to change a little bit.
Probably I'll just interrupt for a moment and explain that we've got the roll center essentially as a point in space, an imaginary point in space around which the front of the car will rotate as it rolls, and we've got a separate roll center for the rear. And then, as you mentioned, you've got this moment arm between the center of gravity height and the roll center height. So then by adjusting the roll center heights individually, front and rear, up and down, then we can change the way the car balance is affected, correct?
Yeah, 100%. Like a road course car is going to be set up totally different in terms of roll center to a speedway car.
Other elements with this as well, once we start learning about concepts like roll center, it seems nice and clear cut, until you actually start tracking how the roll center moves as the car moves around the racetrack, as it turns, as it brakes, as it accelerates, and you start realizing that the roll center is just a constantly moving point. And that's when different suspension geometries and different kinematics come in to make the roll center more stable or less stable. Basically, the amount the roll center will move around can vary quite dramatically, correct?
Yeah, 100%. The way you do it in terms of VD or the math, you choose a static position of the roll center, usually down the center of the vehicle, not when it's yawed or turning. But 100%, it's shifting side to side, up and down. And it can be quite dramatic. Sometimes the roll center can be in the ground. Sometimes it can be in the sky. It just depends on the suspension setup and how much it articulates and what the designer wanted to do.
Just as a really quick anecdotal point I'll bring up here, a lot of people with modified road cars think that by lowering the car, we're going to get an improvement in performance. And yes, that will lower the center of gravity, and we look at race cars and they're all nice and low, so we're getting that cool race car look. The bit that people don't often understand, though, is if we just simply lower, let's say, a McPherson strut suspension setup, and we make no changes to correct the roll center height, the center of gravity is going to drop, but the roll center height will generally drop by more. So what we're actually doing as a result is increasing that moment, that leverage arm, and we're actually going to end up increasing the body roll, which seems totally counterintuitive. But that, again, if you don't understand the roll center and how it's being affected by what seems like a subtle change, that can go completely unnoticed. I think we're probably a little down in the weeds with this now, so I'll bring us back up to the surface, and I wanted to continue sort of talking around some of these sort of challenges I guess you'd have with incorporating IndyCar componentry into your Pontiac. And one of the things immediately jumped to mind while I was sort of crawling all around this car in Sydney is just the minuscule size of the likes of the fasteners that are used for, the rocker arm suspension, physically mounting the wishbones, etc. Obviously, these components are all designed around an Indy car, which I don't know what the spec was. I'm assuming well under 1,000 pounds. You're not, sorry, under 2,000 pounds. Don't quite know where we were. I say that because it converts relatively nicely to 1,000 kilograms. You're significantly heavier than that. So is this a consideration? Is there any concern here around the strength of these fasteners, and are they fit for purpose?
So talking about the fasteners explicitly, they are pretty small. A lot of people look at us and they're immediately going to shear off. They're going to get damaged, or they're not built for this car. And two things are happening. Most people are using lower quality bolts and hardware. And on top of that, they completely overspec their stuff. And a lot of people are coming from truck world or the off-road world where that stuff needs to endure punishment for a long time. And that stuff is huge. We're using NAS grade bolts. And if you look at the shear strength on one of those, they could withstand the weight of a fully loaded semi truck, just suspended from one bolt. So in terms of hardware, we're not concerned at all about the strength of it. Even back in the day with Indy cars, what they were doing is sometimes they wanted to reduce weight from the cars. They had a smoother track. They didn't want to deal with weight, so they were drilling the center of the bolts out. Yeah, so that's an old dirt track thing. Most designers will look at that and they're kind of their hand is in their face, kind of like, why are you doing that? It's better to just kind of spec the right size bolt from the beginning, but it is an old trick that can be used. And if you think drilling out the center of a bolt is not going to reduce much weight, some of those guys, they were doing anything it took to reduce weight. Like a lot of the Indy cars, after about anywhere from 2 to 3 paint jobs, they were stripping the tub down and reducing the weight, and that would be a pound or two right there.
Yeah, wow. It's starting to really get extreme for weight savings.
Yeah, 100%.
All right, so the fasteners, not an issue. How about the componentry, such as the uprights, the wishbones themselves? Again, I'm guessing the IndyCar designers weren't designing these with I can't remember, you said the weight of the car was it 3,500 pounds?
Yeah, with driver wet, it's about 3,400 pounds, which is a bit more than our original weight goal, which our original weight goal was 2,800 pounds, which hopefully, if we can make it back to World Time Attack Challenge again next year, the car will be that weight.
So ultimately, yeah, the question remains, the IndyCar designers didn't have a 3,400 pound car in mind when they're designing the uprights and the wishbones. I mean, it hasn't fallen apart, so obviously you're on the right track. But again, I guess what I want to know is, how do you sort of look at these componentries and have confidence that they are going to be fit for purpose? Is there any sort of FEA going on in the background to sort of validate this, or is it a gut feel?
Originally, it was a gut feel. So right now, those cars at sea level, at peak, down like a high downforce package, they were, even though they were 2,000 pounds, they were making anywhere from 5 to 6,000 pounds of downforce on top of that, which is obviously, if you look at each corner, that's a lot of weight to experience. And on top of that, for speedway cars, even though they don't have a lot of like a high downforce package, they are experiencing a lot of downforce back in that era and a lot of load. And the highest amount of load those suspension components would see is actually at a speedway if they'd hit the wall. So a lot of times those cars, they're literally running fractions of inches away from the wall at times to get the optimal racing line. And sometimes they'll hit, and the worst hit that you'll see is one that you go from low to high, not necessarily one where you're against the wall. It's actually safer to be against the wall. You can understand the same concept if you get a hammer. When you use a hammer, are you swinging it from an inch away, or are you swinging it from back behind your head? Not saying you want to do that, but you get more power from going from a greater distance. So a lot of those suspension components are built to take pretty large impacts, because as soon as they bend or buckle, it's failed. It will continue to bend and it's not in the right geometry. So the components, they're built to withstand some pretty high loads and not fail. But from the initial perspective, what our thought was is, hey, our car's not making as much downforce as a Indy car, but it does weigh more, but it overall evens out to the same amount. But now that we're going back and going for more downforce to make the car more competitive and everything, we're going to start looking at validating that stuff and potentially remaking like push rods. Just because for those of you who don't know how these push rods are constructed, is it's not just an aerofoil tube. If you look at a lot of our suspension or IndyCar suspension, it's not just round tubing. It's actually, imagine just a round tube that's been crushed to an oval profile. It's an aerofoil profile. And if you look at certain parts of the suspension, you'll notice these dots on top of it. It's because there's actually another tube on the inside of it that has been rosette welded. So it's really two tubes put together, and stuff that is going to experience a high load where it might be prone to buckling ends up with those rosette welded inner round tubes. And on top of that, the suspension's heat treated and it's coated.
Yeah, okay, that makes sense. So it sounds like at the moment you're sort of working on the basis of the safety factor built into those original components, and I guess watch this space. If you do develop more downforce, some of these components will also need to be potentially redeveloped.
Yeah, and I know how to do the math behind all that stuff to pick the right size wishbone. Like a lot of the stuff back then, they were doing tons of development to make that tubing as small as possible to reduce the aero impact. It's technically, for the front suspension, it flows, and it might be important, but at the end of the day, the suspension not breaking, which I don't think it will at the moment, is more important. And we have more than enough power to punch through the air, and the air in our fenders is already somewhat turbulent.
It's not like an open wheel wings and slit car where literally everything's hanging out in the breeze, so the aerodynamics of the wishbones is super critical. That's not quite the case with your car.
Yeah, not the case with our car. We can find bigger gains other places in terms of drag reduction. At the end of the day, just going to a larger diameter or thicker wall tubing, or both, will be a major benefit.
Okay. Just with, again, developing parts from a 2,000-pound car into a 3,400-pound car, I'm assuming here that the likes of the damper spec and the spring rates would totally need to be rethought. Is that the case? And if so, how did you go about that?
Yeah, 100%. The car was kind of under dampened and undersprung initially, and we already knew that. So we had the dampers revalved, I think double to what they were, because the car was basically double the weight. So we figured it probably needed double the dampening just to kind of, as a baseline. It was still under dampened and still undersprung. So we just kind of, the general philosophy to get this car set up is starting really soft and incrementally going stiffer and stiffer. And as you go stiffer with the springs, you need to go stiffer with the dampening. And with the Öhlins, the nice thing about these is, compared to like a Penske, they have a very wide range of tunability without even having to revalve the damper. We're running an Öhlins TT44 Gen 2 damper, and it's an older one. Obviously, it was run on the Indy cars back 20, 25 years ago, but in terms of the technology, it's better than what a lot of stuff you can get today. So we're still in the progress of kind of getting it set up. We really feel like it's about 80, 90% of the way there right now. But now that we're going to go with more aero downforce, that's going to be changing again.
Everything starts again.
Yeah, it all starts over, you know.
And when you say the philosophy is to start soft and then add stiffness, it sort of is always a bit of a challenge with an aero car, because obviously the downforce increases dramatically the faster you go. So you sort of either end up on one end of the spectrum with a car that's so stiff that it's got no mechanical grip at low speed, where the aero is not functional or not really effective, or the flip side of that is you end up with a softer car that has good mechanical grip in low speed corners, but then just gets driven into the ground down the long straights. You've got a reasonably interesting way of dealing with that. I mean, again, nothing particularly unique with Wings and Slick's car, but the heave spring arrangement. Can you just give us a high-level view of what a heave spring is, how that functions, and how it helps you?
Yeah, so you were talking about how you want that low speed compliancy where you don't necessarily have that aero grip, but you need to keep the car from hitting the ground or going too low at higher speeds where you do have that downforce. And that relationship increases with velocity squared. So it's not a linear relationship, it's an exponential one. So one of the things you're really targeting, the reason why we start soft is because you really want that compliancy at the end of the day. So if you completely ignore the fact that we have a heave spring, you have to tune for the car not to squash down at the end of the straight because you're having to tune around what's your highest downforce event, usually in a straight line right before your fastest turn in. But then that would sacrifice your low speed corners. So if you can add some kind of arrangement that can move with your dampers, it will allow you to have a stiffer arrangement without sacrificing that low speed compliancy. And in this case, we're running something called a third slider, or what other people call a heave spring. What that allows you to do is you don't have, so on the main springs on the dampers, the springs are, when the car is on the ground, the springs are touching, which means that they're being dealt with all the time. But with the third, usually you have something called a third gap. So you don't have that spring, that third spring being used all the time. You only want it at the top end. So as the rockers go back and as the springs get compressed, eventually that third slider squashes down enough to where it goes into contact with the third. And that's what you call third engagement, where you start to engage the third at hopefully a planned location. Because if you have this arrangement on the front and rear, it's incredibly crucial how you tune those arrangements to work together. Because the last thing you want to happen in this kind of arrangement is for it to happen at the same time, or have them happen at the same time. Because if you think about the way a stool is built, most stools have how many legs? 3 legs. So cars are weird because they have four corners, but at the end of the day, you don't need 4 corners to be stable. It makes a bigger problem at the end of the day, but race cars have 4 wheels, so we work with it. But the big thing is that you need at minimum 3 contact patches to remain stable. And the problem is when you have that arrangement touch on the third, it's almost like it goes down to 1. So if you have both, if you have both touching, it feels like you're almost on a line or on a bicycle.
Okay. So you need to purposely separate the engagement points of the front and rear heave springs. Otherwise, the car feels completely uncontrollable. Is that sort of what you're telling me?
Yeah, 100%. It's not something I would say most people should probably have on their car unless you're censored out and you really understand what's going on. Like
These are high-end componentry, and it's not just a case of adding the heave spring. You need to then, as we're talking about, understand how to set it up, get the best out of it, and like you were just saying, sensors, some instrumentation to actually figure out what it's doing and when it's doing. So there's a lot to this. Is a complex topic that we're simply scratching the surface of here.
Yeah, 100%. There's a lot that's happening behind the scenes to really understand its engagement, how it's being used, how much you need, what you're doing with the setup, especially per the course. But honestly, if you guys are listening, I'd really recommend you Google either the front end suspension arrangement on an open wheel car or an LMPH car or even our car. And there's probably tons of photos of the engine bay because it's kind of, when you describe it, it's kind of hard to understand. But if you can kind of look at it, it makes a lot more sense.
It's definitely a very foreign concept to get, and again, unfortunately, the podcast medium without the benefit of some nice illustrations doesn't make this any easier. But as you say, I mean, people are going to be able to do their own research if this has piqued their interest and they want to learn more. I think again, we're probably about as far down in the weeds with this topic as we want to go. There's one other point with this. So essentially, that heave springs there to, I guess, essentially decouple roll from heave movement. In other words, trying to, again, help stabilize the platform and not drive it into the ground when the downforce really comes on.
Yeah, at the simplest, it's really a device to just increase your overall stiffness at a certain point over a certain speed. That's the simplest way to think about it.
With cars that don't benefit from having a heave spring arrangement, the usual technique is a compromise between spring rates, which we've already talked about. If you go too stiff at low speed, it's not going to be helpful. But then also purposely using packers and bump stops to control the platform height at high speed. When you're incorporating a heave spring, are you still relying on the bump stops on the individual corners of the car, or has that become unnecessary?
So on our setup, we don't really have bump stops, but we could use bump rubbers on our third if we wanted. The big thing is that if you're driving the car and you feel it hit the bump rubbers, it's quite a hard engagement. It's not very smooth. And because we're using this at a lower engagement point, a spring is probably better because it's more additive. Once it hits, it's like, okay, you've increased the front total heave stiffness by what that front spring rate is for the third. And with bump rubbers, you can get softer ones and have a smoother progression, and you can stack them and have a different spring rate. And the math for that to figure out what the total spring rate once it's compressed is not hard, but we prefer springs and there is a kind of a weight penalty when you use springs just because it gets heavier. But in just terms of smoothest of engagement and where we're engaging, we're going to use springs.
Yeah. Okay. Let's come back up for a breath here and talk about something maybe a little bit simpler, and that's the engine configuration. So we sort of talked earlier about what kart we're running back in this time. When you were deciding on an engine configuration, was something like a Cosworth XD ever even a consideration?
I mean, that would have been cool to do. It would have been really neat, but for us, it probably would have not been a good thing to do because we wanted something that was easy to get parts for. Like when we were helping Herta with just a few components, obviously we don't deal with the engine stuff, so we couldn't really help them with the engines. But they were having a really hard time finding valve springs for those Cosworth engines. The valve springs are kind of a wear use item after you run for, especially with like a red tag motor. If those of you who don't know, that there's a difference between a red tag and a black tag motor for those Cosworths. Back in the day, they would actually do engine changes between qualifying and the race day. And the qualifying engines could go 500 miles, and literally 501, 502, they would probably blow up. Or they had a lighter valve train, which allowed them to rev, I think, 250 or 400 more RPM, 400 RPM, but they're not built to last a race distance. So the black tag motors are really the ones that if you're going to vintage race it or use it, you probably want those because
it's got some chance of holding together.
Yeah, 100%. Yeah, it's going to last longer. So the big thing is getting parts, and to be honest, it would be like at the time we just we had like a $30,000 budget. We weren't going to spend a lot of money on it. And the only reason why the car is what it is today is because a lot of sponsors came on and they're like, hey, do you want to use this product? Or hey, do you want help with this? And because of the money they put in, we would put some more of our own money in. But we start off with the LS because the parts are easily available and they're not super expensive. Yeah, that's generally why we went with it.
Fair. I mean, it is a well understood platform at this point, and given your power aspirations, which we'll jump into in a minute, you're not aiming to break any world records on the LS platform or go where no man's gone before, so it's a fairly well-trodden path. There are some considerations around this, though, in terms of torque, which is why I was wondering about the XD. You've got is it a X-Track IndyCar transaxle? Was that the manufacturer, X-Track?
Yeah, that's true. X-Track, they're out of England, but they're the gearboxes that were being used back in the day.
So obviously that is designed around the torque that the the Cosworth engine, for example, produces, which is relatively low torque, but low torque at very high RPM, hence they're still able to make crazy power. When we look at a typical twin turbo LS, we've got huge amounts of torque at much lower RPM, and it's the gearbox doesn't really care about the horsepower. It's torque that needs to manage. So yeah, how did you sort of weigh this up when you were going through the design criteria in terms of making sure that you weren't going to put too much torque through that transaxle? And I guess spoiler alert, you kind of did.
Yeah. Those of you who don't know, at World Time Attack Challenge, we on the first practice day, second session, the car broke something called an angle drive, which we'll get into that later once I answer your question, because this is quite a unique transaxle. It's not like a normal one. But yeah, because of the LS, like back in the day, those Cosworth engines, or a lot of those engines, were making 500 foot-pounds of torque, and it was at higher end, and they were pretty gutless below a few thousand RPM. The LS is completely different. It's not only way bigger, but it's got a lot of torque. Like, we weren't going for power at all on this build. The last thing this car needs is power. We were, right before the gearbox broke, it was spinning in fourth gear at 130 miles per hour. And when it finally did give out, our tuner thinks it was making 1,800 horsepower.
Wow. Okay. That is some power.
Yeah. So that's a whole nother thing. We're still trying to diagnose it. It's kind of hard to diagnose the issue when you don't have the car on hand, because it's currently being shipped over from Australia.
As I understand from chatting to you at World Time Attack, it was put down to potentially an overboost issue. Is that still sort of what you're leaning towards?
Yeah, so one of the things that we were looking at is it kept going over the boost target. It was like just vertical. So there's nothing wrong with the wastegates themselves that we're using. We don't think they're improperly sized. And it wasn't like they were going to be restricted. We think potentially our boost solenoid failed, or it's plumbed backwards, or maybe there's some other issue that we need to investigate further.
To be honest, from tuning cars for a living, I would say that in 4 out of every 5 turbocharged cars that I tuned, where a boost control solenoid had been plumbed in by someone other than our workshop, it was inevitably wrong. And it's no disrespect to you or the guys who installed it either. It's just such a common problem.
Well, in our case, we're actually using one from a Cosworth XD, funny enough. But it's not like a regular 3-port that you would buy today. It's a 4-port. And also, you don't have a ton of instruction manuals off this stuff. And so what ended up happening is, right before the event, we noticed that we were looking at some data from a Utah test as well. And we noticed that the turbos were overspeeding. They were running at 130,000 RPM, and they were in the wrong portion of the compressor range. So we actually ended up melting our diffuser on the car, because we have a rear-mounted turbo setup due to weight distribution. So what we ended up doing is we upgraded from a G35 900 turbo to, I forget the exact one. I think it's a G35 1200 or a G40 something. But we upgraded to a different size, a larger compressor size Garrett. And I said it in one of the recent social media videos, I'm pretty sure. So we were in a way better compressor range. And what we ended up finding is, it's kind of hard to tell when you're just tuning on a dyno. You would think you would be able to find all the stuff, but it's completely different tuning on a dyno to tuning in the real world, like with the car actually moving. And because of the turbos being maxed out this whole time, we didn't really realize that we weren't able to properly adjust. It's a torque-based sensor, so we have it all configured in the car to adjust the torque using the steering wheel. Just because the turbos were being restricted, we couldn't really tell whether we were adjusting the power. And once we went up to a bigger turbo, we realized that we might not be able to control the boost as well as we wanted. So now we're trying to figure out and diagnose this stuff. It's honestly kind of teething pains of a vehicle, especially teething pains developing this quick.
Totally understandable. I think I'm a big advocate, and I have been my whole career, of wherever possible. Once I've been on a dyno, I will take the car out. If it's a road car, it's road legal. I'll test and confirm the tune out on the road. If it's a race car, we'll take it to the track and do some testing and shakedown and make sure everything we saw on the dyno matches what we're seeing at the track. But one of the big factors that does often dramatically change is the boost control. It's really easy on a dyno to do a ramp run and get a boost curve that you can lay a ruler across. Just, it doesn't fluctuate more than 1 to 2 kPa, and that's great. But then often you'll take that same vehicle out on the racetrack and find that the boosters are either significantly above or below what you were seeing on the dyno. And then the bigger issue as well is quite often transient. So the car might respond perfectly when you're at wide open throttle down a straight, but often where you roll into the throttle coming off a turn, that is where it will actually overboost significantly. So these are all the things that really need to be factored in. So the dyno is just one tool, and we don't race the car on the dyno. So really what it does out on the racetrack is the important part anyway.
Yeah, 100%.
I would also just say a little note on the 4-port solenoids. There's those that love them, there's those that hate them, and I'm purely assuming here that this Cosworth 4-port solenoid works how I expect a 4-port solenoid to work. These typically give us a wider boost range between what we'd call our minimum or wastegate spring pressure. Let's say we put a 10 psi spring in the wastegate, and we kind of get around about 10 psi as our minimum boost. With a conventional 3-port solenoid, we might be able to get from, let's say, 10 psi to, I don't know, maybe 20, maybe 22. There's so many factors that will limit it, and that's our range of boost. And often that's not going to be enough. So one way of getting a wider boost range is to use a 4-port solenoid. The problem with that, though, is we tend to trade a little bit of resolution or granularity with our boost control for that extra range, meaning that for every extra % of duty cycle we add, instead of, let's say, getting a 1 psi increase in boost, we now might get a 2 psi increase. So that actually can really play into the boost control strategy as well. I've tended to sort of move back away from 4-port solenoids myself, but I think they're only also necessary or useful when you need that wide range, and if you can get away without that, then I don't really see they serve a purpose necessarily.
So I guess I have a question for you. Would you step away from a 4-port and go to like a 3-port?
I personally would, but I am speaking a little out of turn, having had no involvement or understanding in the setup of the car. So, I don't know enough about the setup to be able to definitively say you have got the wrong solenoid on there. But, again, if you don't need a dramatic range in your boost control, then the 4-port really doesn't give you any advantage and just simply makes your life more complicated, at least in my experience.
Yeah, one of the things we were trying to do is the car can make up to 25 psi of boost, which we don't really need. When we were on the dyno last time, we made around 1,500 horsepower on the dyno with like 14, 15 psi of boost.
That sounds pretty spicy.
Yeah, RPM helps a lot, and just a really high quality engine build. And it's also got 850 lift.
Okay, that's plenty.
Yeah, so it's also got the biggest valves in LS I've ever seen. So the engine is completely built to rev and breathe, and also fuel helps a lot. We're running VP X98. It's 98% ethanol, and I'm sure they put something else in it because when it burns, it smells like a methanol. It also probably helps cool the exhaust a little bit.
It's interesting you say that as well, but something we haven't mentioned so far is you're actually not running any intercooling on this engine, are you?
No, not one bit. And early on in the project, I used a program and some basic kind of math to figure out what is the maximum PSI we can go to before we start seeing high inlet temperatures, because obviously high inlet temperatures can lead to pre-detonation, and overall just high inlet temperatures is just not good. And I found that the number this was a long time ago, around 15, 16 PSI. So at lower PSIs, it would just increase very slowly from 80, 90, 100 psi, and all of a sudden, as soon as you hit from like 15.9 to 16 psi, it all of a sudden shot to 200 degrees Fahrenheit.
Yeah, it's quite a substantial jump.
Yes, and it's a completely non-linear relationship, and it's kind of that's why I had to use a program to kind of model it a little bit. So my philosophy was like, we don't need the power. It's insane. Like 1,200 horsepower is almost impossible to put down, let alone 15 or 1,800 horsepower. We just need an engine that revved a lot, and we just want to put the turbos in the right compressor range.
I guess with no intercooling as well, the compressor efficiency really becomes even more critical. Naturally, when you compress air, it's going to be heated up. But then the other factor that comes into that is whereabouts you're operating in the compressor efficiency. So if you're, let's say in the low 70% range, you're going to be adding less heat than if you're operating at 55%, for example. So you really want to try and make sure you're in the meat of that efficiency range.
Yeah, that's why we were looking at the compressor efficiency, like you said, so much when working with Garrett on trying to properly size the turbos. It's been a labor of love. It's been a lot of work to figure out what's going on with the car at this point, and yeah, it's been kind of a crazy build.
I think it's fair to say that if it was easy, everyone would be doing it. So these things do come with their challenges, and it's frustrating at the time. I'm sure no one was really excited to see the transmission break at World Time Attack, but these are the challenges that a car like this is going to lay down.
Yeah, and we not that we need to go over a certain psi range, but if we need to cool the air charge, back in the day they used a PCI, pre-compressor injection. We've kind of stayed away from it at this point just because blasting fuel pre-compressor actually can hurt the turbine blades. Also having it, if you've looked at the interior of our car, the charge tubes are run right next to your arms, so that's also not good. And then due to the intake, the front, because our intake's backwards, the front two cylinders probably wouldn't get enough fuel. They'd be leaner compared to the back cylinders. So we've kind of stayed away from that. We would be willing to spray water. That might work, but honestly, as long as we stay below a certain psi range, our inlet temperatures are fine.
I mean, it ultimately sounds like you're making more power than you need within a range that doesn't require any additional thought on cooling. So to me, it would make sense to just focus on keeping the boost there and everything else should fall into place.
I completely agree. That's been our strategy the whole time. And also on top of that, intercoolers are weight.
Yeah. Well, I think the bigger issue, obviously, for your installation is a packaging problem because you've got mid-rear mounted turbochargers. Getting airflow to a air-to-air intercooler is therefore going to be difficult. Water to air would be achievable, but that brings its own packaging problems and, as you mentioned, weight. So it's just a whole bunch of weighing up which compromise you want to go down.
Yeah, we've looked through all those, and I think a PCI would be the best route of action.
It's something I've never had the opportunity to play around with, but yeah, I'd be very keen to give it a crack. I know exactly what you mean, though. Everything I've read about it, if you don't achieve correct atomization, then you can end up doing damage to the compressor wheel. My understanding as well, though, when set up correctly, it actually gives you an efficiency boost on the compressor wheel as well. So there's sort of two advantages to it.
Yeah, I keep coming back to this, but the whole point of this project is to learn and use it as kind of a laboratory / test bed. Why do something everybody else is doing? Probably because it's simple and it's a lot easier, but you don't learn anything from that. You learn, hey, a front splitter is going to work for this because the pressure builds on top and the air flows underneath. It's like, okay, but like, what if you try to put a wing up there? What challenges do you get trying to make that flow? Now you have to deal with the tire. Now you deal with the vortice trying to go, depending on where that end plate ends, you deal with the vortice going inside the wheel well or outside the wheel well. What challenges do you have to deal with the flow after that? So this whole car has been a project test bed to kind of just learn and try weird things, but not so weird that the car's not going to work.
Yeah. Seeing as you just started to mention some of the aerodynamic effects there. Let's dive into that. You can't go to World Time Attack without some fairly advanced aero, and the Hammerhead sort of fits the bill nicely. How did you develop what's on the car at the moment? You kind of alluded to earlier that you're about to go through a complete redesign of this.
Yeah, so we work with Veris Engineering. They've done the aero for the Hoonipigus, and if you know who Horizon Motorsport is, I think if you had him on the show recently, he's got like a DTM style BMW, and that actually has the most downforce out of any other car they've designed before. And we kind of came to them halfway through the project saying, hey, like, now that we've put more power on the car and looking at the gear speed calculations and looking at all this other stuff, we're kind of thinking aero is needed, because something that goes 204 miles per hour like this car probably needs to stay glued to the ground, especially if it's a road course car. So we really like working with them. They're a really good bunch of guys. They work extremely hard. They're constantly developing products. I mean, I think Eric and Matt don't stop or don't sleep. They're really neat guys. So
Well, what's the process of working with Veris to come up with what you've got on the car at the moment?
So what ended up happening is at the very beginning of the project, we kind of came through, showed them the car, told them what we were thinking on certain things that we had built, and they went, okay, and started scanning the car. The first thing they needed to do is, because we didn't have a CAD model of the car, and we were just kind of building it freehand, they needed to scan the car and use that data, that scan data, solidify it, and then use the solidification to make a solid model or a surface model for CFD testing. We had some certain things on there that probably didn't make sense aero-wise that they could immediately tell, and they were being extremely kind, and we said, hey, just be honest. You're not going to hurt our feelings or anything. We like just looking at it. Do you see anything that just doesn't make sense or doesn't work? And they go, and they listed off like 5 or 6 things that we need to change. And within a week, we had changed those things and added them. And they were like, holy crap. So they ended up having to actually come back and rescan the entire front end of the car. And based off those improvements, I'm sure it was a massive change. But obviously, that was just kind of a general spitball of things to change. But that's kind of been our base that we've worked from there. And once they've started doing testing, they gave us a preliminary result, and it was like, okay, well, we got some work to do. So we've been kind of restricting because we've been just kind of quickly developing the car, which is part of the reason why we're going and saying, hey, like it's time to put a real kit on this car, because we just kind of wanted to see how far we get with just kind of using parts from the scrap bin in a way.
But at some point, you really need to come up with an integrated solution that's going to be perfected for the car.
Yeah, like we don't make a bad amount of downforce. I think we make slightly less I think we make a little bit less downforce than the Hoonipigus does. But also, if you think about it, the Hoonipigus is a smaller vehicle, and we have a lot more surface area to play with. So we're kind of to that stage now to where it's time to develop a proper kit. We got to a pretty significant number in our book, but in order to make the car truly competitive and function, it's time to put some more on there. So what they would end up doing is, because this is all about learning, and it's great that they're working with us on that. So I would send them a part that I modeled and say, hey, is it possible to integrate this into your model? And they go, we'll give it a shot. And they were able to get it integrated. So now I send them components that we're going to put onto the car, and I 3D scanned and modeled it and sent it to them, or something I designed and then they put it on there. Like the main thing that I designed on the car that we actually integrated for an aero piece was the diffuser. So I sent them a model for it, and then they integrated and said, hey, it's a big gain. We think it'd be worth making. So I ended up using that design, and we ended up building that diffuser. And if you look at videos of it, I mean, it completely cleans off runways.
How do you go about turning a virtual part in a computer CAD model into a physical component that you can bolt to the car? Is this something you guys are doing in-house?
Yeah, so we're starting to do a bit more of that now. Like initially, it was kind of build something, then I reverse engineer it and send it to them, and that was kind of the old school way of thinking that with my dad. And now I'm kind of like, hey, it's time to like do the modern process where it's like design something in CAD. Instead of trying to optimize where it goes, you optimize it bespoke for that location, and then you take that part and you design it. So in that case, what we ended up doing is I had the part file, so I ended up making a few drawings, and then ended up because it's so large and because of the way we're building it, we built it out of a huge amount of like wood and MDF board and fiberglass paint, just mold. It's a carbon piece, so mold making, it's just crap on top of crap on top of crap with a really nice surface that you can roll the mold to.
So arts and crafts 101.
Yeah, it's really just expensive arts and crafts at the end of the day. So what I ended up doing for the diffuser is I sliced in a bunch of sections to get the main profile of it, and drew out a bunch of templates to not only use for honeycomb cutting, but the carbon layers, and then using those templates and the general shape of the diffuser at certain sections, because the first 2/3 of it is pretty linear. It doesn't really change a lot in terms of looking from the side, but if you look at the top, it's kind of like a Coke bottle shape. It's wide at the front, and then it kind of narrows up and then goes wider at the back. And then there's the kind of flat pieces that come out of the side that had a shaped profile to it. So I just made a bunch of templates out of paper, like a thick cardboard type paper, and placed it around and made sure I measured from certain points from my model and built it from there. Luckily with carbon stuff, you lay bigger than the piece that you're going to make. And the main stuff that needs to be properly sized is like the honeycomb and hard points. And then you can trim it afterwards.
Without sort of trying to derail this whole conversation and go down a complete new rabbit hole, just in terms of the construction of that, what was the method you're using there? Is this a wet layup, vacuum bagging, resin infusion?
So just like everything else on this project, we do something way too complicated for our own abilities.
Jump out of the plane and then build the parachute on your way down.
Yeah, basically. We had done a lot of metal fabrication on the car and some design stuff and machining, but I really wanted to learn more about composites. So this diffuser was kind of a way to do that. Oh man, this thing was way too complicated. The way it had to be laid up, especially with the time schedule we had, it was laid up in actually 3 pieces and kind of bonded together. So there was a top and then the sides. So the way that we ended up doing it was all wet layup, and there were certain parts of it that we had pre-wet out the fabric and lay it down, and then certain parts that we had wet out later on, just depending on how we wanted to, whether we want stuff to adhere a certain way or how hard it would be to move an entire piece of fabric. Because it was so large, it required 2 or 3 people to move pieces at a time. Just to put this in perspective, I don't remember how long our car is, but if you've seen it in person or generally know what the scale of it, about a third of the length of the car has a diffuser underneath it. So it's about as wide as it is long, and it tapers from no height practically to almost like 2 feet. So it's quite a massive piece. It has tons of honeycomb in it. Actually got replaced with kind of a foam like material recently. It's got hard points in it. It's got a bunch of pre-cured carbon. It's such a complicated layup.
Now, I think when I was talking to you at World Time Attack, we're talking about the bodywork in general, and obviously this notwithstanding maybe a complete redo of the aero anyway. At the moment, all the bodywork, the external bodywork, is steel, as if I recall correctly.
Yeah, that's completely correct. The front fenders, the doors, the roof, the rear quarter panels, the trunk is actually carbon. The hood is fiberglass, the nose is fiberglass, the entire floor of the car is a honeycomb. It's kind of like airplane floor, where airplane floor is fiberglass, aluminum, honeycomb, fiberglass, where carbon, aluminum, carbon. And it's also got, I don't know why I'm blanking the name, Kevlar. It's also got Kevlar in it for anti-intrusion. We just didn't want anything to come up and poke anybody.
That'd be nice. I mean, this would seem to be a relatively low-hanging fruit in terms of getting a bunch of weight out of the car, just redeveloping that steel bodywork into composite. Is that something that's on your mind as well, or have you got too much PTSD from the diffuser?
Yeah, the diffuser was a really good thing to do because at the end of the day, it turned out pretty well. It ended up working. It was an improvement, and it showed me just about how large you should make things. That's about the limit. So something like a door would honestly be so easy, especially our doors. They're like big, but they're not diffuser big. So I would just do it in two skins. I would have an outer skin and inner skin. And if I really wanted to make it stiff, I would probably do some honeycomb just because we're taking away the thickness of the door. I'd probably sandwich an inner layer with Kevlar in it. I'd do a Kevlar layup. I mean, because we're not wheel-to-wheel racing, it probably doesn't matter, but just if you have a crash event, you never know what you're going to hit or run into. Yeah, I mean, at the end of the day, we don't want anybody to get hurt, and it's not worth the weight savings if someone gets hurt from something.
Not at all. All right, so the car's not quite made it back stateside yet. I guess from here, other than, again, notwithstanding the aero development, what's left to sort out? When's the car likely to be seen on track? And at least in the US, what events is this car likely to be competing at?
So one of the first things we want to do when we get it back is it's going to be in California where we pick it up. Some guy really likes the car and he wants us to run it and help. So he's going to let us use his garage space at Thermo Club. And he said his track is available 24/7 whenever you want, and there would be no rush. So we're going to probably take development pretty slow and just work out any teething pains in terms of power unit and drive it and just deal with whatever we've got and get it to the point to where all it's going to take is really just build the aero components and put them on the car. So it just hasn't had a lot of track time, and this is probably a good 3-day opportunity to get a lot of track time, a lot of miles. And so we got some slicks that we can use because we didn't end up using them at World Time Attack Challenge. So we're still wanting to track the car and use it. It's hard to say what events we'll be at. It's quite expensive to run a car like this, and it was kind of crazy to do that across the world for its first time ever. So as long as we can get support for an event, we'll do whatever it takes to get there. The thing is that World Time Attack Challenge is really the main event, or really only event, that is big enough that we can make work.
Sure.
Otherwise, it's kind of private testing, and like Grid Life is an awesome event. It's a really neat event. I've seen Hyperfest. I know people really like that. And then Global Time Attack puts on some good events. But the big thing is for our sponsors, a lot of our reach is through social media. And obviously, anywhere we go, the car's got a crowd around it, 3 people deep at times. But in order to actually bring it to events, we usually have help from sponsors with that.
Yeah, fair. I guess as well, it's easy to forget from this side of the world just how big the US is. So if you want to be carting that car all around the United States to attend different events, it's a fairly big commitment, both financially and time-wise.
Yeah, like not only driving there, but you're dealing with usage of your vehicles and usage of the car, which at the end of the day, that's what you're there to do. But you're talking about tires, you're talking about fuel. If you have a driver, or you're talking about staff potentially. And luckily, a lot of the people who help, they're volunteering their time. We just make sure it doesn't cost them anything to help us. But I mean, a lot. It's just awesome because the only reason why this car is happening is because of so much support from other people.
Yeah. No, I mean, it's become a bit of a fan favorite, so I can understand why that's the case. Oh, look, Cavan, we're getting on towards the 2-hour mark, and we could probably go on for another 2 hours, but I do want to respect your time, so I think we'll sort of move towards wrapping this thing up. We've got the same 3 questions, of course, we ask all of our guests at the end, and the first of those is, what's next in the future for you? I guess we've probably touched on a little bit of this as we've gone, but maybe you could tie a nice little bow around it and sum it up for us.
Yeah, so a quick answer to this is I'm going to be finishing my degree in the next year, and I'm going to continue to be working on Hammerhead to develop it, hopefully take it to more events and keep people entertained with that and continue to learn. I have the car bug so bad. I mean, I always have a build idea that I want to do. I mean, I have 5 build ideas I want to do, but they're just to put this out in the world. I do have an S14 shell, and due to everything that I've learned on the car, I think I could build a car that would put, I don't want to say Hammerhead to shame, because there's nothing wrong with Hammerhead. I mean, I'm super proud of the car. The amount of work that we put in is insane. But, you always look at something, and I'm such a perfectionist. I feel like with the lessons I've learned on this car, I could build something even crazier.
And I don't doubt that, but and that does come down to that sort of where you put the line in the sand in terms of not letting perfection be the enemy of good enough. I guess at some point you've got to get the car out there on the track, on the road, whatever it might be, and actually use it so you can learn what worked, what didn't work, which is obviously exactly where you're at the moment.
For sure. And at the end of the day, we just want to keep developing Hammerhead and keep running that. And I'm going to keep learning. And eventually, I mean, a lot of things in my life have happened at the right time. So I'm just going to keep doing what we do.
Okay. This next question, I'm just going to struggle to ask this one with a straight face, given your age. But let's see how you handle this. Is there any advice you give to a younger version of yourself to help reach where you are today in your career faster? I don't know how you fast track what you've done, but let's hear it.
More stimulants. No, I was kidding. So, to be honest, it's such a funny question, because if I think back about all the stuff that I've been doing the past few years, the only way I could get through what I've done faster is if I didn't competitively swim in high school.
Okay, we skipped this, but good to know. Competitive swimming.
Yeah, that took a ton of time. I was waking up for swim meets, I'd be waking up at 3, 4, 5 in the morning, and for swim practices, I'd have do that 2 times a day. And if I wasn't swimming second time that day, it was a weight room. And so that could take anywhere from 4 to 5 hours of my day right there.
To be honest, it's all starting to fall into place now. That dedication to swim competitively, or do any competitive sport for that matter, I feel like you've just segued all of that energy and dedication just into a different area of your life now.
Yeah, all that energy and all the craziness is going other places. And to be honest, even now that I'm saying this, I don't think I would skip out on the swimming part, because it taught me a lot. Like I can wake up anytime now or work late, and it taught me a lot. So I think it's an important stepping stone. But if I was min-maxing everything, I guess I'd remove that part and work on the car sooner.
I think you're doing just fine. All right, our last question for today. If people want to follow you and see what you're up to, how they're best to do so, what's your social media?
Yeah, so the thing that I'm most frequently on is Instagram. It's Horizon _motorsports _LLC. We're also on YouTube, but it's not very big, and mainly Instagram is the main source of content for us.
Oh, as always, we'll put links to those accounts in the show notes to make it easy for people to find. Look, Cavan, it's been a great to catch up again. Really enjoyed chatting with you at World Time Attack and learning more about the car, obviously diving in even deeper in the podcast today. So thank you for your time. The car is an absolute credit to both you and your dad. We wish you all the best of success with it for the next year, and with any luck, we'll get to see it again at World Time Attack next year.
Yeah, for sure. Well, thank you so much for having me on the show. I've been a long-time follower, and I've really enjoyed your content. And thank you.
No, thank you. I hope you've enjoyed this episode of Tuned In, and don't forget, by using the code podcast500 at checkout, podcast listeners can get a huge $500 off our VIP package, which includes over 40 current courses, as well as a long list of courses to be released in the future. As a VIP, you'll also get lifetime access to our members-only webinars and our community forum. Lastly, we'd love it if you could leave a review or comment on your preferred podcast platform. Your feedback really helps us to reach a wider audience, which in turn allows us to continue bringing you more high-quality guests. As a thank you, each week we'll randomly select a review or comment from Spotify, Apple Podcasts, or YouTube and send the winner a free HPA t-shirt shipped anywhere in the world. It's also a great place to ask any questions you might have too, and if your review or comment is chosen, I'll do my best to answer them directly. So this week, a big shout out to BT Maxid, I think it is, from New Zealand, who has said, awesome podcast, enjoy the variety of topics and well presented. Some really valuable info shared. Thanks for the great content. No problem, it is absolutely our pleasure, and I'm glad to hear that you're enjoying it. If you get in touch with your t-shirt size and shipping details, we'll get a fresh tee shipped straight out to you. All right, that concludes our interview. And before we sign off, I just wanted to mention, for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.